Okay, so now let's talk about making a hypothesis. First of all, what is a hypothesis? A hypothesis is a testable statement So a testable statement that predicts the outcome of an experiment and let's add that it also provides support by using research. So when we were in elementary school, we would say that a hypothesis was an educated guess. So we want to kind of move past that because we don't want to just say that it's a guess. It's educated because we use research. So we're not just kind of coming up with it all by ourselves. But it's also, it's considered a guess because it's a prediction and it hasn't been proven yet. But it's important to also remember that it's testable and that it is a complete statement. Okay? So we also want to add that it is fact-based. That means that it is not an opinion. So you're not going to say that Sims is better than Pace High School. The word better is not a fact. It is an opinion. It is your opinion. So we also want to make sure that because we say that it's a statement, that it is a complete sentence. Alright, it's also going to, because it is testable, alright, that means that, testable means that it's going to, means it is going to lead to an experiment. Alright, so let's go over what the format would be. If it's a statement, if it's a complete sentence, there's kind of like a template that you would use because you would make your hypothesis after you have already identified your variables. So since it is a prediction statement, we're going to put if, then we're going to explain our independent variable, then we explain our dependent variable. We have our because segment because that is going to be our support. So here is where you would place in your independent variable. Okay, so for example, you would say if the amount of sunlight was changed for each plant, then the plant height, so that is our dependent variable. So you have to have your experiment kind of planned out before you can make your hypothesis. And you have to have done your research first. So if, and then we put our independent variable there, then, because we're explaining that this is going to be affected by this, and then we put in our support. Okay, so this is where we're going to plug in our research, information. Okay, this is where we put in our support. Alright, so we do not use, I want to add this, okay, there are no personal pronouns. So we're not going to put, you know, I think that this will happen. We never, ever, ever start a hypothesis with I think that. Okay, so let's look at some examples. All right, so if we're going to look at what makes a good hypothesis, remember that it's fact-based, that it's testable, and that it's a complete sentence. So if we're looking at these, we're just going to mark whether it's yes or no. So men are better drivers than women. We know that better is an opinion, so that would not be a good hypothesis. Men have fewer driving accidents than women. Can that be tested? Yes, it can. 42. It's a number. It's not a complete sentence. There's no more information, so that would be a no. Undetectable aliens live all around us. Whether you believe it or not, that would be a yes, because we could test to see if there were aliens around us. If a faucet has a wider opening, then the rate of flow will increase. That one is in a great statement there. If and then. Now the only thing it's missing is its support. But that still makes a good hypothesis. Okay, so let's look at another one. All right, if you are given an experiment and you have to come up with a hypothesis, this would be a great example. Tom knows that the amount of water a tree gets affects how fast it grows. He wonders whether the amount of water a tree gets will also affect when its leaves change color. So he decides to water one tree a lot and another not at all. So a hypothesis could be, if the amount of water is changed, then the leaves will change color because trees need water to grow. I just noticed a typo right there. I'm so sorry. All right, so we have our if, and our amount of water that the tree gets is our independent variable. Then the leaves will change color. So this isn't measuring data, but that's the outcome variable that we're looking for. And then we have our because. So let's look at number 2. Marlene's class will be doing experiments with gravity. Marlene wants to investigate which ball will fall to the ground first, a soccer ball or a volleyball. So for this one, we could say, if a soccer ball and a volleyball are dropped, then, and this is where we would put in which one we think would fall first. We're going to say then the soccer ball will fall first because it has more gravity because of its weight. Now, this is just an example, okay? So we know that there's a soccer ball and a volleyball. Let me add that right there. Soccer ball, and she's wanting to know which one will hit the ground first. Okay, so we have put it into the format. First you identify your variables, then you plan it out, okay? If, and then you explain your variables, your independent variable, then you explain your outcome. What outcome are you going to be measuring? And then you put in your because, something to support why you think that's the outcome, okay? Let me know if you have any questions.